This video will, in short, in a nutshell, will give us an idea of how many types of layers are there for deep learning. We know there are multiple layers. Each layer is having a purpose, a functionality, and the example for Python coding will also be discussed. Basic layers, the significance of the layers, description. Basic layers: input, hidden, and output layer. In the input layer, it passes the data directly to the first hidden layer, where the data is multiplied by the first hidden layer weights. Coming to the hidden layers, it's located between the input and the output of the algorithm, in which the function applies weights to the inputs and directs them through the activation function as the output. In implementation using this Python, there's the dense. You can use the Keras library, where dense is the function where we can mention the units, input shape, and the activation function used. In this example, the activation function used is ReLU. Output layers. It is used for producing the final result in the neural network. In this, the activation used is softmax. The function name is same as dense, but activation is used here is softmax for multi-class classification. Input layer. Input can be a sequence of numbers, it can be images, it can be time series data. So there can be many types of data which can be fed into the artificial neural network, the deep neural network. So it's image input layer, sequence input layer. This list tells us about the learnable layers. In the learnable layers, one of the very common and popular one where the images are used is convolutional 2D layer. It applies the sliding filters to the input. It convolves the input with moving the filters from vertically and horizontally, and computes the dot product of the weights and the input, and then finally adds the bias term. It transports conv 2D layer. It upsamples the feature maps. There is a fully connected layer which multiplies input by a weight matrix and again adds a bias network, but all the neurons are connected from the previous layer to the next layer. LSTM layer can be found in a feedback neural network, which is also called recurrent neural network. It enables the time series data and the sequence data in a network for prediction. It is used. So they are best suited for learning long-term dependencies. Coming to the activation layers. Activation layers is responsible for performing a threshold operation for each of the element. Like there are variants of this ReLU. So ReLU layer, leaky ReLU, clipped ReLU, normalization, and the dropout layers. So this particular layer normalizes each of this input channel across a mini batch. It will normalize the activation of each of the channel by subtracting the mini batch mean and dividing that by the standard deviation. So this speeds up the training of the convolution neural networks and also reduces the sensitivity to the network initialization. There is a cross-channel normalization layer, and there is also a dropout layer. The dropout layers helps us in solving the overfitting problem, and it randomly will set up the input elements to 0 with a given probability. Coming to the pooling layers. The pooling layers are mainly used to perform downsampling by dividing the input into rectangular pooling regions and computing the average value for each of the regions. There can be a variation. There can be 3 types of or more than 3 types of average pooling, 2D layer, max pooling, max unpooling. These are combination layers. Combination layers, additional layer, depth concatenation layer. It takes multiple inputs having the same width and height and concatenates them along the 3rd dimension. The requirement is all the inputs to this addition layer should have the same dimension. Output layers. Finally, coming to the output layers, it can be a binary classification, it can be multi-class classification, it can be for regression tasks. Depending on that, we call it softmax layer, the classification layer, the regression layer. Here in this example, we can see the output layers where the sigmoid is used for binary classification and softmax is used for the multi-class classification. The loss function used for the binary classification is called binary cross entropy, and for the loss function it is categorical cross entropy. This is one example where MNIST data set of handwritten digits have been classified. So this is multi-layer sigmoid neural network with 784 input neurons, 16 hidden neurons and 10 output neurons. 10 output neurons consists of the digits 0 to 9. The conclusion, different layers we have seen they perform different transformations given an input, and some layers are better suited for some tasks than the others. And if it is the type is a sequential data, it is a time series data, then we use a LSTM layer. If it is just the image data, then we use the convolution layer. So each, depending on the data types, depending on the task, the layers are used and they are formed. The multiple layers are formed in a sequence to perform the tasks. As the model learns, the weights of all the connections are updated and optimized so that given the input, it maps to the correct output and the prediction class obtained matches that of the target class. Thank you.